So, hello friends, and welcome to the next part of the tree series. And in this part, we are going to solve a very interesting question, which is invert binary tree. So, this is the question for today. And here, what we have been given is that we have been given a binary tree, that means root of a binary tree, and we have to invert the binary tree. Now, let's understand what is the meaning of inversion in this case and how we are going to do this. So, here you can see that I have taken the example one from the question, and the example you can see that this is the given binary tree, and this is our inverted binary tree. Now, what is the meaning of inverted binary tree? Let's understand that first. So, what you can say is that if you assume a mirror, so if you assume a mirror here, so if you assume a mirror in between these two given binary tree and the output binary tree, what you can simply see that these two are mirror image. So this is very simple to understand that the node which is closer to the mirror will comes closer in the mirror image also. So that's how the whole order has been changed. Here 9 is close, so then first 9, then 6, then 3, then 1. So this is completely the mirror image. So now we have understood that the binary tree which we required is an inverted binary tree, means it is a mirror image. Now how we are going to find the mirror image, so this is important. Now let's focus on that. So what you can say that what we can do is that we have to change the positions of the given tree. So the positions of the nodes are changing, and how it is changing is very ordered fashion. So if you assume a line, imaginary line, between the first root node, what you can see is that the position of these two nodes at the first level, so let's assume these are first level, second level, and third level. So the nodes at the second level here is changed in the required image of the binary tree. So in the image you can see that the positions are changed. Now again you can see that if you see the separate this root only, so if you take this binary tree, what is you can simply see that the position of the nodes in this binary tree, which is 6 and 9, is also been changed. Here you can see that 9 comes closer and then 6. So in this order you can understand that for every node the left and right part has been swapped. For 4 the 2 and 7 has been swapped. For 7, 6 and 9 has been swapped. For 2, 1 and 3 has been swapped. Here you can see 1 and 3 has been swapped. So this is the only thing which we need to find out. That means for every node we have to swap left and right. So now the questions become very simple, that we have to run a recursion and we can call left and right, and we can simply swap left and right. Now when you are going to stop, so when you are going to get null, that means your root is equals to null. So when your root is equal to null, what you have to do? We have to simply return null. That means you have to do nothing. So you can simply return null, or you can simply return here directly. You can return. So we can directly return. So in other cases, when it is not null, what you have to do? We have to swap. We have to swap left, comma right. So this is the recursive function which is going to give us a mirror image of the given binary tree. We have to swap the both left and right, and we have to stop when root is equals to null. Now let's apply this. So what we have to do is that we have to check the first stopping condition, which is if our root is equals to null. So we can simply use if it is null. So what we have to do, we have to simply return null. It is capital. Now next, if it is not null, so what we have to do, we have to swap the left and right part of the root. So first what we can do, we can take a temporary tree node. We can take tree node star temp, and we can appoint root left. So we have restored root left in the temp. Now we are going to change the root left. So our root left is equals to root right. Now next what we are going to do, we are going to write root right is equals to temp, because we have already changed the root left. So this is a simple swapping logic which we are using since our array part. So using this logic, what we are going, we are swapping the nodes. So you need to understand that we are not swapping the values, we are simply swapping the whole tree, that means the whole part, because we are here taking the pointers. Now what we have to do next is that we have reversed, or you can say swap the left and right part. Now this is done. Now we have to make sure that the left part we and right part we just have swapped are also been inverted tree. So for that, what we are going to do, we are going to call two functions which are going to invert those two left and right part, which is root left and inverted tree root right. So what these two function will do, it will call its recursively and it will also invert the its own. So it will also invert its own and it will simply return the root. So we have to simply return a root. Now let's run this code. So this is accepted. Now let's submit this. Okay, so this is submitted. So this is the question for today, and this is an interesting question because here we have to simply make a logic out of it by understanding how the nodes or how the roots are behaving. So we have simply understood that the left and right part of the every node has been swapped every time, and that's how we are going to get the mirror image. So this is an interesting question for today, and you are going to see the solution for both Java and Python. And now let's meet in the next video to solve a more interesting questions from tree. So keep tuned to our YouTube channel. Thank you.